Good day everyone, here we are at EE 323 Renewable Energy, and we are the Uncanny Counter. My name is Karen Joy B. SERAFICA as a hustler, Tom A. Castillo as a hacker, DEZYLYN G. MATEO as a hipster. We already discussed the types of renewable energy, from tidal energy, solar energy, and hydrogen energy. And now, we will discuss the geothermal energy. Now, let's read the basic information of geothermal energy. Geothermal power plants are used in order to generate electricity by the use of geothermal energy, or the Earth's internal thermal energy. They essentially work the same as coal, solar thermal, nuclear power plant, the main difference being the heat source. So, geo means ground or earth. Thermal means relating to heat. So, geothermal energy is the type of energy that can produce electricity by means of heat from the ground or earth. Now, let's proceed to geothermal power plant working principle. There is natural source of power found below the surface of the earth that has been around for centuries. Underground, far below us, there are pools of water heated by magma or molten rocks. These pools of water make up geothermal reservoir, harnessing the power of the Earth's temperature to power, heat or cool our homes, and business is power. This geothermal principle stated that there is natural source of power found below the ground, which is 2 to 3 kilometers below, and there are pools of water heated. These pools of water make up our geothermal reservoir. By harnessing the heated water, the power of the Earth's temperature to power, directing to turbines and connected to generator, and the generator generate electricity. And this is the ranking of largest geothermal was recorded in January 2017. The top of the list is the United States. The second one is the Philippines. Next, the third one is the Indonesia, followed by New Zealand, Italy, Mexico, Turkey, Kenya, Iceland, Japan, El Salvador, and Costa Rica. Next pa rin natin is the ranking of largest geothermal. The top 10 geothermal countries was recorded in 2019. Unang-una pa rin dito ang United States, sumunod dito ang Indonesia, at kasama pa rin sa top 3 ang Philippines, followed by Turkey, New Zealand, Mexico, Italy, and Kenya. So why Philippines is on the top of the list of largest geothermal energy? The Philippines is one of the world's top producer of geothermal owing to its location along the Ring of Fire zone of the Pacific volcanoes. And this is the MARBEN geothermal energy, where it is located at Laguna. As you can see, the smoke thing in the figure is not harming the environment. It is the steam from the water vapor. So remember that MARBEN geothermal energy is located at Laguna. This is the figure of the geysers geothermal power plant. Next is the geothermal power plant with respect to ideal location. The most active geothermal resources are usually found along major tectonic plates boundary, where most volcanoes are located. One of the most active geothermal areas in the world is the Ring of Fire, which encircles the Pacific Ocean. So to be most active geothermal resources of the country, it must be along in the major tectonic plate boundaries kung saan ang mga volcanoes ay matatagpuan dito. And Philippines is one of the top lists in geothermal resources because of the so-called Ring of Fire, which encircle the Pacific Ocean. So when magma comes near the Earth's surface, hits the ground's water trapped in porous rock or water running along fractured rock surface and faults, hydrothermal features have two common ingredients, the water or the hydro, and the heat or the thermal. Geologists use various methods to find geothermal reservoir. Drilling a well and testing the temperature deep underground is the most reliable method for locating a geothermal reservoir. These reservoirs are deep underground and largely undetectable above ground. To study the ground and find geothermal reservoir, geologist is the one who study the areas. It is stated that drilling a well and testing the temperature deep underground is the most reliable method for locating a geothermal reservoir. And nabanggit natin kanina na ito ay dapat may lalim na 2 to 3 km below the ground. Continue the ideal location, geothermal energy find its way to the Earth's surface in 3 ways: the volcanoes, fumaroles, hot spring, and geysers. Unang-una narito ang volcanoes. Di ba sabi kanina, the location must be along in major tectonic plate boundaries, kung saan matatagpuan dito yung mga volcanoes. Next is the fumaroles. So ano nga ba ang fumaroles? Fumaroles are openings in the wind-earth surface that emit steam and volcanic gases such as sulfur dioxide and carbon dioxide. They can occur as holes, cracks, or fissures near active volcanoes or in areas where magma has risen into the Earth's crust without erupting. So, next is hot spring and geysers. So ano nga ba yung pagkakaiba ng fumaroles and geysers? Geysers are distinguished from both hot spring and fumaroles by their specialized plumbing system, while the difference between a hot spring and a fumarole is simply the degree of heating. So nagkakaiba lang daw sila sa degree of heating. Next is the hot spring and geyser. Diba alam na natin yung hot spring? It is the steam from the water vapor. Next is the geyser. Let's define the geyser. A geyser is a rare kind of hot spring that is under pressure and erupts, sending jets of water and steam into the air. Geysers are made from the tube-like hole in the Earth's surface that runs deep into the crust. The tube is filled with water.
There are 3 types of geothermal power plant. First is the dry steam power plant. Next is the flash steam power plant. And then last is binary cycle power plant. So first is the direct steam power plant. So direct steam power plants are the most common types of geothermal power plants, accounting for about half of the installed geothermal plants. They work by piping hot steam from underground reservoirs directly into turbines from geothermal reservoirs, which power the generators to provide electricity. After powering the turbines, the steam condenses into water and it's piped back into the earth injection well. So para ma-visualize natin, here's the diagram of the working principle of dry steam power plant. So dito, yung mismong steam na yung na-extract natin mula sa deep within the ground 2 to 3 km below. So yung steam na yun will be piped directly to the turbines. So dahil doon, iikot na yung turbines natin na connected sa generator na iikot din. Kaya makakapag-generate tayo ng electricity. Then, i-step up na siya. Then, pupunta sa substation. Sa substation, dito natin i-step down to 269. Then, i-step down ulit natin siya sa another step station to 13.8 kV. Then, pagkari nun, i-distribute na sa consumer. So, yung excess steam, magkukulo up to, magkakaroon ng condensation. Yung condensation, ito yung process from gas to liquid. So, yung water na yon will be sent back to the underground. Then, paulit-ulit na yung process. So, here's the another diagram of working principle of dry steam power plant. So, the next type of geothermal power plant is the flash steam power plant. Flash steam plants differ from dry steam because they pump hot water rather than steam directly to the surface. These flash steam plants pump hot water at a high pressure from below the earth into a flash tank on the surface. The flash tank is at a much lower temperature, causing the fluids to quickly flash into steam. The steam produced powers the turbine. The steam is cooled and condenses into water, where it is pumped back into the ground to the injection well. So para ma-visualize natin, here's the diagram of the working principle of flash steam power plant. So dito ang hina-harness yung hot water. So dito ito yung brine. So dahil sa sudden change of temperature and pressure upon reaching the surface, it will turn into steam. So katulad niya kanina, yung steam na yon will be piped directly to the turbines na connected sa generator. So sa pag-ikot ng generator, makapag-produce tayo ng electricity. So hindi lahat ng hot water will turn into steam. So iba mapupunta sa injection well and then it will set back to the underground. Then yung steam dito magkukulo up, magkakaroon ng condensations. So sabi nga kanina, ito yung process from gas to liquid. Then yung water dito will send back into the ground. Then paulit-ulit na yung process. So here's another diagram of the working principle of fast steam power plant.
This is the third type, the binary cycle power plant. In these binary cycle plants, the main difference is that the water or steam from below the earth never comes in direct contact with the turbines. Instead, water from geothermal reservoir is pumped through a heat exchanger where it hits a second liquid like isobutene, which boils at a lower temperature than water. This second liquid is heated into steam, which powers the turbines that drives a generator. The hot water from the earth is recycled into the earth through the injection well, and the second liquid is recycled through the turbine and back into the heat exchanger where it can be used again. So, unlike to the other types, in this type, the hot water will extract and go to the heat exchanger. And here is another liquid that will be heated through the extracted hot water, then it will evaporate and become steam. So it is connected to the turbine and to the generator. And upon the rotation, it will generate electricity, so the excess water will send to the injection wall. And that is the cycle. So this is what I said.
Geothermal energy gives us a steady supply of electrical power with minimal environmental impact. Here is the basic process. Water in underground reservoirs is heated to high temperatures by magma. Production wells drilled up to 10,000 feet below the Earth's surface tap into this hot fluid. Under its own pressure, the fluid flows through these wells toward the surface. As it travels, the pressure lessens, causing a small amount to become steam. Together, the hot fluid and steam move through a surface pipeline to a wellhead separator, where the pressure is reduced. Here, most of the fluid vaporizes and flashes into high-pressure steam. Any fluid not flashed into steam moves to a standard pressure crystallizer to produce standard pressure steam. Remaining fluid is then flashed at a lower pressure to create low-pressure steam. All steam created in the plant is sent to a turbine on site. The force of the steam spins the turbine's blades, which turns a shaft connected to an electrical generator. An electrical charge is created and directed to a transformer, where the voltage is increased and sent down power lines. Any fluids not flashed into steam return to the underground reservoir, where, in time, they will be reheated and reused. Geothermal energy, a simple, clean, and renewable energy source.
Let's proceed to construction cost. So in terms of construction cost of geothermal power plant, it is also expensive, but in terms of during operation cost, it becomes relatively low because of renewable resources. So here the advantages. Some advantages of geothermal power include its sustainability and consistency. Geothermal energy is renewable, so it's both more environmentally friendly and less susceptible to natural resource wars than fossil fuels are. Geothermal can consistently produce energy, output 24/7, regardless of weather conditions or seasonal changes. So also we have disadvantages. The disadvantages of geothermal power are the geographic limitations and high costs associated with power plant construction. This needs to be built over region with underground reservoir of hot steam or water. Though it's technically possible to engineer enhanced geothermal systems in unsuitable environments, it's highly impractical to do so. EGS requires extensive space, planning, construction, and government oversight and capital, and can only be accomplished by a federal or state governments and corporations.
To continue our discussion, this is the last topic of renewable energy resources. The hydroelectric power plants are also known as hydropower. Hydropower in terms of working principle. Hydropower plants capture the energy of falling water to generate electricity. A turbine converts the kinetic energy of falling water into mechanical energy. Then, a generator converts the mechanical energy from the turbine into electrical energy. So, a hydroelectric power plant is a process of producing electricity by means of using falling or fast-running water. Hydropower provides benefits beyond electricity generation by providing flood control, irrigation support, and clean drinking water. Hydropower provides low-cost electricity and durability over time compared to the other sources of energy. This is achieved by converting the gravitational potential or kinetic energy of water source to produce a power. So from the generator converts the mechanical energy from the turbine into electrical energy. So this is the largest hydroelectric power plant. The first one is the Three Gorges Dam, the Itaipu Dam, the Silwado, Bellomonte, Guri, and yung country niya, China, Brazil, and Venezuela. So sa Three Gorges Dam, gumagamit ito ng 22,500 megawatts. Years of completion, 2008 and 2012. Next is the Itaipu Dam with 14,000 megawatts. The Silwado with 13,860 megawatts. The Bellomonte with 11,233,000. And the last is the Guri with 10,235 megawatts installed capacity. So kasunod ng ating largest hydroelectric power plant is the Tukurei, Grand Coulee, Xiangjiaba, Longtan Dam, and Sayano Shushenkaya. So ito matatagpuan, the Brazil, United States, China, and Russia. So kung mapapansin nyo, sobrang yaman ng China sa ating hydropower plant. So to continue our discussion, let's talk about the Magat Dam. So ano bang meron sa Magat Dam na to? The Magat Hydroelectric Power Plant is one of the largest hydro facilities in Luzon with a maximum output of 380 megawatts. So ito daw yung one of the largest hydro facilities or hydropower in Luzon with 380 megawatts. The construction of the dam started in 1975 and was completed in 1982. So, kung bibilang natin yung taon, ito ay ginawa within 7 years. Next is, it is one of the most largest dams in the Philippines. So, yung Magat Dam, one of the largest dam daw siya sa Philippines. It is multi-purpose dam which is usually primarily for irrigating about 85,000 hectares of agricultural lands and power generation through the Magat Hydroelectric Power Plant. Next is the dam is located within the boundaries of Namilangan, Alfonso, Lista, Ifugao, and Ramon Isabela. So, yung dam na daw ito ay located sa Namilangan, Alfonso, Lista, Ifugao, and Ramon Isabela. Note, combined cycle power plant and Suwal power station in the largest in the Philippines with a generating capacity of 1,200 megawatts. Luzon grid has a total capacity of 14,348 megawatts. Three Gorges Dam in China has a capacity of 22,500 megawatts. So kung mapapansin nyo, yung Luzon grid natin ay mayroon 14,348 megawatts. At yung difference naman ito sa China, yung Three Gorges Dam, meron siyang capacity na 22,500 megawatts. So this is the actual figure of a Magat Dam, the one of the largest dam in the Philippines. So now, how do hydroelectric power plants operate? Ito yung mga parts ng ating hydroelectric power plants. The dam, intake, turbines, under yung turbines nandun yung generator, and transformer, power lines, and outflow. So, dito muna tayo sa dam. Dam, most hydropower plants rely on a dam that holds back water, creating a large reservoir. Often, this reservoir is used as recreational lake, such as Lake Roosevelt at the Grand Coulee Dam in Washington State. So, ano nga ba ang dam? It is a barrier preventing the flow of water. So, sinasabi na nga dito, it is a dam that holds back water. Next is the intake. Gates on the dam open and gravity pulls the water through the penstock, a pipeline that leads to the turbine. Water builds up pressure as it flows through this pipe. An intake is an opening, structure, or system through which a fluid is admitted to a space or machine as a consequence of a pressure differential between the outside and the inside. The pressure difference may be generated on the inside by a mechanism or on the outside by dam pressure or hydrostatic pressure. Next is the turbine. The water strikes and turns the large blades of a turbine which is attached to a generator above it by a way of a shaft. So when the water released from the reservoir flows through a turbine, spinning it, which in turn activates a generator to produce electricity. So under the turbine is the generators. As the turbine blades turn, so do a series of magnets inside the generator. Giant magnet rotate past copper coils, producing alternating current by moving electrons. So alam naman natin, the generator is the one who produce or generate electricity. Next is transformer. So the transformer inside the powerhouse takes the AC and convert it to the higher voltage current. So, di ba yung step transformer, dito natin siya ina-apply. Next is power lines. Out of every power plant come 4 wires, the 3 phases of power being produced simultaneously, plus a neutral or ground common to all 3. So, yung power lines, ito yung mga power plant na natin. Next is the outflow. Used water is carried through pipelines called tail races and re-enters the river downstairs. So, yung tinawag sa ating water is carried through pipelines ay tinatawag daw itong tail races.
So, these are the parts of hydropower plants. We have reservoir, dam, generator, transformer, powerhouse, power lines, outflow, turbine, penstock, control gate, intake. So, at hydropower plants, water flows through a penstock, then pushes against and turns blades into a turbine to spin a generator to produce electricity. Let's watch this video.
To generate hydroelectric energy, you need 2 things: an abundant supply of water and an elevation to drop it from. Building a dam creates both. The dam creates a reservoir which stores water until it's ready to use. Water enters the generating system through a series of giant intake pipes. It then travels down a steep pipe called a penstock, creating a massive column of water with a huge amount of force. At the base of the penstock, the water passes through a turbine. The giant blades rotate the drive shaft in the turbine, which is connected to a large generator. This converts the mechanical energy into electricity. The electricity travels along high-voltage wires to transformers, then onto transmission towers, where it connects into the provincial power grid. After passing through the turbine, the water continues through the tail race where it rejoins the river below. A hydroelectric dam is a remarkably simple, sustainable, and clean way to generate huge amounts of power.
Let's move on to the construction of hydroelectric power plants. So, the construction of these dams is difficult and about intensive, of course. Before construction begins, water is diverted or prevented from moving through the construction site. After water is diverted, the foundation area is excavated, and rock or sediments that will act as the foundation are repaired and deemed solid. This is done to ensure the rock or sediments won't shift or fail as a result of the load of the dam and reservoir. Supports known as rock boils and melting may be used to prevent rocks from falling on the dam, and concrete is pumped in. This is done in sections and the concrete is poured bit by bit in a block formation. Once enough of the dam is filled, the reservoir is allowed to fill in a highly controlled manner. The dam is during this process, other structures that make the dam operational are then added. Next is the different dam design of hydroelectric power plant. So the common here is the gravity. And we have the arc, the buttress, and the embankment. We can see here the material that will be used, and the sectional view, and the plan or the top view. Next is the schematic layout of hydroelectric power plant. Ayan siya. Makikita natin dyan yung mga parts niya din.
Next, the main factors that determines the dam power output. The amount of electricity a hydropower produces depends on two factors. First is how far the water falls. The farther the water falls, the more power it has. Generally, the distance that the water falls depends on the size of the dam. The higher the dam, the farther the water falls and the more power it has. Scientists would say that the power of falling water is directly proportional to the distance it falls. In other words, water falling twice as far has twice as much energy. So sinasabi lang dito na mas malayo pinanggagalingan, mas malaki yung power. Kasi nga, directly proportional yung distance it falls sa power of the falling water. So the second factor is the amount of water falling. More water falling through the turbine will produce more power. The amount of water available depends on the amount of water falling down the river. Bigger rivers have more falling water and can produce more electricity. Power is also directly proportional to river flow. A river with twice the amount of flowing water as another river can produce twice as much as energy. So hindi lang yung distance it falls yung directly proportional sa power, kundi pati rin yung amount of water falling. So directly proportional sa power dahil pag more water falling, mas malaki yung mapoproduce na power. So the tallest dam in the world is the Nurek Dam na matatagpuan sa Tajikistan. It is 984 feet or 300 meters tall. Samantalang yung Hoover Dam is 726.4 feet or 221.3 meters tall. Today, Hoover Dam still ranks in the top 20 of the tallest dams in the world, but only in the concrete gravities and arch categories. Sa itsura ng Nurek Dam, which is the tallest dam in the world. So dito naman tayo sa may dam failures. So noong 1975 sa China, 26,000 dead from flooding, 145,000 dead from subsequent famine and epidemics, 11 million homeless, cost loss of generation dam failed by overtapping in a 1 in 2,000 year flood. So noong 1979 naman sa India, nag-collapse yung dam, leading the deluge of the city of Morbi and the surrounding rural areas. 1,800 to 25,000 people were killed. So the latest dam failures is noong 2017 sa United States. Damage bill will cause evacuation of 108,000.
That's all for today. Thank you for listening.